Hello everyone, welcome back. This is Michael Jum, the MJ of Think Academy. Again, I'm back, your teacher Michael. How's everyone today? Well, I think I can notice that most of you we've seen before. And remember last time we learned how we cut our pizza into more pieces, that is to have more intersections of the cut. And then we learned some formulas of n lines and how many pieces can we get given n lines and how many more intersections can we get at most. And this time, instead of just cutting the circles and the planes, the lines, we are going to have more real world problems, and you will see how we can use this knowledge of induction into real life. Okay, let's begin. So here are the steps. Why are we going to do the steps question? Remember last time we got so many pizza to eat, and so personally, teacher Michael again had pizza for his lunch today because, well, I personally want to try what technique we just learned last class. I tried to cut the pizza into so many pieces, first cut, second cut, third cut, and I ended up with eating so many pizza and my stomach was so full. That's why I will say that, well, I'd like to do some exercise like climbing the stairs. So let's do this together. And there are 10 steps. There's a little rule that we can either go, well, one step or two steps at a time. And we can see here on the graph, we have from 1, 2, 3, all the way up to 10 steps. If we can only just climb 1 or 2 steps at a time, how many different ways can we get? Again, 1 or 2 steps at a time, 1, 2, 3, 4, all the way up to 10 steps. There seems to be a lot of ways. I can 1, 2, 2, 1, 1, 2, 1. Oh, how can we do this? Remember what we learned from last class? Start with the simple case and then enumerate for a few more cases, look for the patterns. That's exactly how we are going to tackle this problem. Okay? But before we start, let's do some simple definition. Here we know that if we only just go one step at a time, that is, we know it is like we climb up one step. That's why I'm going to write it here. Climb is 1, but we can also go 2 steps at a time. I'm gonna call it jump. You can call it any way you want, like crawling, walking, hopping, jumping, any way you want. I just wanna differentiate between 2 ways we can do this. So let's begin. And to get to the first step, how many ways can we do it? We start from the ground. Yes, we can either just go from the ground up 1 step, and here we are at step 1. There's nothing else we can do. And I'm going to summarize our finding on this graph like this. And this is a 1, indicating that we have only 1 way to get to the first step. Okay, then how about the second step? How should we get to the second step? If we can either climb, that is 1 step at a time, or we can jump, that is 2 steps. Okay, great. That is, we can climb from the first step we will be standing from. Okay, so that's 1 plus 1. Is there any other way? Yes, remember we can also jump. Where should we jumping from? Right, that's 2. We jump directly from the ground. And in total, we have how many ways to get to the second step? Correct, that's 2, because we can either climb from the first floor or jump from the ground. Again, let's proceed to the third step. And here, I want everyone to pause a little bit and think carefully about our strategy here. We can either climb or jump. That means we can start with one of the technique first. How about we start with the climbing? Where should we be climbing from? We want to get to the step 3, and then we use +1, which is climb. Where should we be at before we climb to the third step? Yes, we should be at step 2 if we just want to climb. So we are going to write like this. +1 means we climb. But also, we have the ways to get to the step 2, like here. So we just +1, adding this +1 at the end of the road we already have for step 2. And here we have 2 ways to climb to step 3. But remember, is there any other way we can get to step 3 except for climbing? What else can we do? Correct. We can jump. We can jump, that's +2, from where? From the first step. See? So this one, to climb from the second step, contributes 2 ways to get to step 3. And to jump from the first step contributes 1 way. And in total, how many ways do we have here? Yes, we have 3 ways to get to the third step. Okay, guys, are you starting to find the pattern here? Remember, Michael just said, again, we are going to enumerate a simple case and then we look at the number to look for the pattern. 1, 2, 3. Do you find a pattern here? What should it be on the 4th floor? I see. Someone's showing me 4 and someone is also showing me 5. Which one is the correct answer? Oh, no worry. Let's check it out together. Remember, we start either from climbing or jumping. So what if we choose climb first? Where should we be climbing from? Yes, from step 3. So we just copy what we have here. We first get to step 3. Then at last, we +1 means we climb to step 4. And also we have this. Okay, 1 + 2 + 1. So to climb from step 3, we have 3 ways to get to step 4. But what else do we have to get to step 4? Right. We can jump. Where should we be jumping from? Step 2, correct. So we are going to write it like this. 1 + 1 means we get to step 2, and the +2 at the end means we jump. Also, we have 2 here, 2 + 2. So in total, to jump from step 4, okay? Either we can climb or jump. Climbing has 3 ways to do so. Jumping has 2 ways to do so. So how many ways in total do we have to get to step 4 this time? Okay, yes, we have 3 + 2 is 5. Now do you know the pattern here? 1 + 2 is 3 and 2 + 3 is 5. Why is that? Because, right, to get to the step 3, we have either climbing or jumping as our method. So we look backwards to the place where we either climb from or jump from, which we have 1 or 2 ways. So we just add them together, we get 3. Means how many ways we can get to climb or jump to the third step. And similarly for step 4, we look back from, I can go either from step 3, which is climbing, or from step 2, which is jumping. And we either have 3 ways or 2 ways to get to the previous 2 steps. That's why we add them together, we get 5. Without any more enumeration, can anyone tell me what should be the number we have to get to step 5? Correct. We have 8. And why is it 8? Perfect, because we either climb from step 4, which has 5 ways, or we jump from step 2, which has 3 ways, plus them together we get 8. So in this way, let's speed up a little bit, climb all the way up to 10, okay? We do it together. So to get to step 6, what should be the number? Yes, it is 13, because just the previous two numbers added together. Step 7. Yeah, 21. Again, we look back the previous two steps. The two numbers, put them together, should be the answer for the new one. Okay, step 8. Yes, 34. We are almost there. Step 9. Okay, 55. All right, last step. What's the number there? All right, 89. So how many of you got the same answer as Michael? Wave your hands. That's good. We are getting to it, right? For every new step, we look previous two steps and we sum them up together because I didn't do this one or the other one. That's why 2 ways, add them together, get a new answer. So how about we do a simple practice to test if we really get this? Okay, here we have 9x, and we can either eat 1 or 2x in one day. So how many different ways can we eat up all 9x? This will actually be quite similar, if not exactly the same as the previous step question. And I will give you about 3 minutes to do it. So 3 minutes after that, we are going to check it together. Start now. Okay, time is up. How many of you get the answer? Raise your hand for me. Okay, great. A lot of you got this because it's really quite similar to what we just done before. So let's check how we can apply the previous exercise to this question, okay? And here, look, I'm drawing another step. And you see from 1, 2, 3, and this step will end up at 9 steps. So 9 steps, 9 eggs. Are there any relations? Okay, let me explain it to you. Let's see if we have 1 egg at the first day. How should we say? If we just look at this question, if we only have 1 egg, how many ways can we eat this? Well, just one, right? We just eat the first egg on the first day, done. What if we want to have the second egg? If we have 2 eggs, it is actually, we can either eat 1 egg each day. That is, we have 1 plus 1. Or we can eat those 2 eggs at once. Well, that will be 2. So, does it look familiar to what we just climbed? The steps question. It's like if we just eat 2 eggs, it's like we jump, right? Go up 2 steps at a time. If we eat only 1 egg at one day, it's like we only climb 1 step at one time. So eating eggs and climbing stairs, you can just like say, just like, okay, every time I eat an egg, I will climb 1 step. So jumping means eating 2 eggs. Climbing means eating 1 egg. That is exactly just another step climbing question. Now is even one less step to climb. In this case, remember how we should tackle this problem? To get to the first step, that is to eat the first egg, well, we have pretty much nothing else except to just do this, okay? So here we have 1. We have 1 here, right? And then, let's see, we climb to the second step, and there's only, see, 2 ways, because we either eat 1 egg at the time, and we spend 2 days, 1 plus 1, or we can eat 2 eggs in 1 day. That is just like we either climb to the second step through climbing from first step, or we jump directly front ground to the second step. And here we will have 2. Again, let's do it. The third step, that is to eat the third egg. If you want to eat up to 3 eggs, you have to eat either, well, finish up with 1 egg, or you should eat 2 eggs already. That is 1 plus 1. Okay, now only have 1 egg left, you just eat this one. Or 2 plus 1. Okay, at the first day you eat 2 eggs, and the second day you finish up the third egg. What else do we have here? Remember? Jumping, climbing question and the egg here. What can we be ending up with before we eat the third egg? Yes, we can. I mean, the first day we only eat 1 egg, and the next day we eat 2 eggs. So we end up with 3. And we have 3 here. I really need to do more enumeration because this graph and the way I'm doing it are exactly the same when we are doing the steps climbing question. So now what we need to do is just to write up the number all the way up to 9, right? How about we just do it together? To get to the 4th step, remember how many ways can we do it? We look previously the 2 steps. We either jump or climb. How many ways can we jump to the 4th step? That is to jump from the 2nd step. Yes, we have 2. And how many ways can we climb from the 3rd step to the 4th step? 3. So in total, we will have how many ways? Yeah, yes, as I just wrote here, 5 ways. 1, 2, 3, 5. Remember, that's exactly the numbers I wrote on the step question, so we can just walk all the way up through it to the number 9 step. Okay, for number 5, what's the number? Tell me. Yes, it should be 8. How about step 6? Okay, it's 13. Good. How about 7? Yeah, 21. No, it's just all the way the same up to the step 9. We just add the previous 2 numbers and get the new number. Step 8, what's the number? Yes, 34. Step 9, the nice egg. How should we be eating it up? How many ways? Yes, 55. Remember, this 55 exactly the same as we just climbed the number for the step 9. And that's exactly the same here. Remember, look previously for the previous answer, and then those 2 will help us derive the new number. Okay, and then we are going to see another example. So here, after we climb the stairs or eat the eggs, we are satisfied, we go home and take a rest. Then you know what? A little bee called Betty, she also wants to get home. And we are here to help she get to her home. And the little rule here is like this. Betty can only go from a smaller number to a bigger number room. That's like this. From room 1, she can go to, let's say, from small number to a bigger number room. That's this. Either from 1 to 2 or 2 to 3. Here's a question. Can Betty go from room 3 to room 2? And I'm going to label it like this. Can she go this way? From room 3 to room 2. I see you shaking your hands. Why she cannot go this way? Yes, because 3 is bigger than 2, and Betty can only go from a small number to a bigger number. That's why we cannot do it here. And we can actually go from room 2 to room 3, from a small number to a bigger number only. Okay. Again, we are having 8 rooms here, and let's do with the simple case to start. So if we want to go to the first room, how many ways can we do it? Yes, only one. It is just one. We enter this first room. There's no other way. And I'm going to label it this red number to summarize how many ways can we get to this room. How about room 2? How can Betty get to room 2? Yes, from room 1. So we can write this, 1 to 2. Any other way she can go to room 2? Can she go from room 3 to room 2? No, she cannot do so. That's why this way, we only have one way to get to room 2, that is from room 1. Okay then, how about room 3? How many ways can we get to room 3? Anyone just enumerate for me? We can either go from room 2, right? From room 2, we shall write it like this. Okay, but don't forget, to get to room 2, we have to use our root here. So that's why I'm writing this, 1 to 2, and then 2 to 3. Is there all we got here? Do we have any other way to get to room 3? Oh, look at my graph here. What did I just draw? Yes, we can also just go directly from room 1 to room 3. That's this. And that's how many ways do we have here to get to room 3? Yes, we have 2 ways in total, right? Because we can either go from room 1 or either we can go from room 2. So we just sum the number of ways to get to those 2 rooms. That's 1 and 1. Together, we get 2 ways. Okay, Maybe this is still hard for us to observe any pattern. 1, 1, 2. We only know 1 plus 1 is 2, but so what? We can just do one more enumeration, and I hope everyone will find the pattern after this case, okay? To get to room 4, how many ways can we go there? Say, let's see, we can go either from room 3, correct? And like this. Or we can go from room 2. So how should we write the root here based on what we already have for room 1, 2, 3? How should we get to room 4? Yes, we can first write, let's say, room number 3. That is 3 to 4. Now don't forget, to get to room 3, we already have our roots here. Like this, okay? So we just copy it, all right? 1 to 2 to 3. Or to get room 3 of this, we can do this way. Okay. So going to room 4 from room 3, we have in total 2 ways. Any other way we can go to room 4? Yes. We can go from room 2. Now don't forget, we still need to copy the root all the way from room 1 to room 2. So this way, it contributes 1 way to get to room 4. So how many ways do we have in total to get to room 4? Yes, we have 3 in total, right? We have 3 in total, and I'm going to write it like here, 3. So do we start to see a pattern here? Anyone, if you see the pattern, well, just show me your hand. And if you do not see it, no worry, I will explain to you. Just want to check. Okay. So let me explain this. For the third room, number 3, we either go from room 1 or room 2. So we add them together, right? We have either 1 way or 1 way. That's why we add them together. 1 plus 1 is 2. And to get to the 4th room, we either go from number 2 or number 3. And respectively, we have either 1 way or 2 ways to get to room number 2 or 3. So we add them together. It's 3. 1 plus 2 is 3. So to get to room 5, where can we be coming from? Where 2 rooms can we be coming from? Right, either room 3 or room 4. So what are the numbers respectively for room 3 or room 4? I just wrote it here. Yeah, we have either 2 or 3. So based on our pattern we just found, how many ways can we get to room 5? Yes, correct. Because we either go from 3 or 4, and it has 2 ways or 3 ways. We add them together, we get 5. So that means we start to get the pattern, and we do not need to rely on the enumeration. We just use the pattern of the numbers to get to every new answer and get back and get all the way to room number 8. So what should be room 6? Yes, it should be 8 because, right, we look to the previous 2 rooms, room 5, room 4, and how many numbers do we have either for room 5 or room 4? Yes, that's 5 and 3. We add them together, we get 8. So room 7. Yes, it should be 13. Okay, room 13. And how about one last room? What should we get? Yes, that's 21. Perfect, guys. You really get into this, right? You know how to do it. We first do some enumeration, room 1, room 2, and room 3. And then we know this pattern, like for every new room, you look back from the previous 2 rooms you just visited and count on the number of ways you can get to either of those previous 2 rooms. And you sum them together, you get a new number. Okay, just to test if you really get this, I'm going to get you a practice. Well, pretty much the same. Pretty much the same. So I believe it should be easy for you. And this time, again, 3 minutes. And after 3 minutes, let's check it out together. Okay? Start. Okay, time is up. How many of you got the answer? Raise your hand. Okay, so many of you got the answer. So this seems to be not that hard for you, right? Let's do it together. Let's see. This time we are having, well, something kind of special. We have room A and room B. But if you think about it, you can just change any number you want. And how many rooms do we have here in total? 11, right? We have 11 rooms. Is it something like you go from room 1 to room 11 and the same rules as before, smaller number to a bigger number, and you are asked, say, if I have 11 rooms in total, how many ways can I have to go from the first room to the 11th room? Well, that's exactly how we are going to do here. So we have to start from room A, right? So from room A, we can go either, say like this, to room 1 or room 2, correct? And from room 1, as we know before, then rules is the smaller number to the bigger number. So to room 1, we can go for room 2 or room 3. So here are this. How can we be starting this journey? Now let's do some enumeration. To get to room 1, how many ways do we have? Okay, that's here. We just enter it. That's room A, and we only have one way, as we did before. The starting point, we only have one way to reach it. That's to enter the starting point. Okay, nothing fancy. That's easy. And to get to room 1, as I just draw on the graph, how can we get there? Right, from room A. That's why I'm going to write it like this, A to 1. And still, we only have one way here because we cannot go from room 2 to room 1 or room 3 to room 1, right? Why is that? Yes, because 2 and 3 are bigger than 1, so we cannot go this direction. That's why we only have one way to do so. And how about let's do some more enumeration, and I hope you guys are starting to find this pattern here. To get to room 2, how many ways do we have? Right, see the arrow on the graph? We can either go from room 1, right? But don't forget, we get to room A first, A, 1, 2. Or we can directly go from A to room 2. So here, how many ways do we have? Right, we have 2 ways. Remember, what did we start with our previous Betty beehive problem? 1, 1, 2. Because to get to room 2, we have either go from room A or room 1. And the number to go to those 2 previous rooms are 1 and 1. And we 1 plus 1 together, we get 2. Exactly the same pattern as Betty. So without more enumeration, and let's see, how can we get to room 3? Here I just draw on the graph, the arrow here, right? We can either go from room 1 or room 2. And we have one way and 2 ways to get to room 1 and 2 respectively. If we can either go from one of the room, how many ways in total can we do to get to room 3? Yes, correct. That is 3. Right? 1 and 2. Get them together is 3. All right, let's proceed to the next room. Number 4. Right, that is 5. And then room number 5. Yes, that is 8. We just plus the 2 previous numbers together. Then how about 6? Right, add them together, we get 13. The next one? Yes, 21. Just the previous 2 rooms, 8 and 13, we get them together is 21. How about room 8? Okay, that is 34. And room 9? Perfect, that's 55. Okay, our final point, room B. Yes, it is 89. Okay, so everyone, did you understand it? With your hand for me if you understand it. Okay, good, good. Now we are becoming genius of finding the way home or climbing the stairs. Well, we just look for the pattern and our number can help us find the answer. So here, I'm going to have another practice for you. And this time I'm only going to give you 2 minutes because, again, this is exactly the same kind of questions. And for this graph, I will give you a little hint. That is, if you flip it over, make it horizontal, it will just be exactly like our beehive problem, okay? So 2 minutes, counting, go. Okay, time is up. How many of you got this question? All right, if you have the answer, raise your hand for me. All right, great, almost everyone. Now, this question will never trouble you again, right? So let's just do it so simply, right? So to get to the start point, how many ways can we get there? The room one, right? Again, we only have one way to get to the starting point. And then how should we get to the room two? See, I wrote it here, right? Only room one to room two because small number to a bigger number. And there's no other way. So we are going to write here again, just one. And how about the third room, room number three? Again, let's see. We can go either from room one to room three or from the second to the third one, okay? So remember how we wrote on the graph and then used the number to look for the pattern there? Because we can either go from room one and room two, and we have one way and one way to get to those two rooms. We add them together, right? So we have two here. Okay, I see someone starts to get bored, right? Because when you find this pattern 1, 1, 2, and the new room comes from the way to get to the previous two rooms, yes, you just start to write the numbers. No more arrows, no more enumeration, not even you need to have this graph. So we just write a number here to get to room 4. So how many ways in total can we get there? Okay, that's 3. Remember? 1, 1, 2, 3. Similar pattern, right? So room number 5? Yes, 2 and the 3 is 5. How about room 6? Yes, that's 8. And room 7? That's 13. The previous two numbers, we add them together. Room 8? Yes, 21. And room 9? Okay, that is 34. Just as we just did before, like this is exactly the same thing, but the graph is flipped. So don't be troubled by the graph. Use the number, okay? So that's pretty much for today's class, and let's do some little summary here. Okay, what should we learn in this? This is what I call the backward induction, right? Everything from the third step or the room 3, we have already room 1 and 2, those previous example. We use what we have for the previous case and look for the future cases. And also, it's like this. We have past, we have present, then we can predict the near future. And then for even far away future, we use present and near future. We can go all indefinitely in the future. And also again, we are using number to solve the graph problems, right? The number here. And we just have a sequence like this, 1, 1, 2, 3, 5. Remember, that's exactly the number we are keeping writing on the graph as we look for the pattern. And this sequence has a special name, but I will keep it for the next class. If you want to see me and check out what the sequence is called, make sure to check out for our next class in the future. Oh, by the way, if you want to see what it is like for us to meet in person in the future and also to take class with all of our classmates together, make sure to follow our account and enter our WeChat group. Teacher Michael will be there and many other teachers will be there to answer any of the questions you have about Think Academy, about this class, about any general math question, that's okay. So make sure to have a screenshot or take a picture if you cannot scan the QR code right now. And also, there will be some more trial class in June, as shown at the calendar here. So if you are curious about what the real class will be, or if you just want to see Teacher Michael once more again, okay, make sure to scan the code, register, and we will see you in the future. See you next time, and I hope you enjoy the time with us together. I definitely enjoy the time with you. Love you.